Hello, N4H&H here. Look out the shack window. Sunny day. You know what that means in ham radio? You guys know what that means, right? Antenna day. Go out and do some antenna work. Okay, I'll admit it is sort of cold here. I think it's in the 40s right now. As a matter of fact, let me check. 44. It's 44 out there. But I'm going to chance it. I'm going to bundle up because I don't know if you can see it or not. I'll try to zoom, but out the window is my ZS6BKW. Let me zoom out there. Hopefully you can see it. Look at the top left of the screen and you'll see some ladder line, some window line, and right above the, as a matter of fact, let me do this. I'll walk over there and I'll point. I know that the blinds are a little bit in the way, but right above this little sticker here, look up that way and you will see the junction where the coax screws into the window line. You'll see a little bit of it's kind of swaying in the breeze right now. That's where the SO239 is that it connects to, and then the ladder window line technically comes into that as well, and they join. So right now, the coax that I'm using is RG8X. It's actually been out there since I moved into this house in 1998. And actually, I've owned it since 1991 because it used to feed a G5 RV that I just bought on just in a ham radio outlet one day and just needed a quick antenna. So I bought a ready-made G5 RV that came with 75 feet of RG8X. So I just repurposed it. It didn't have a PL-259 on it before. It was basically just sorted inside of a PVC tube with some ferrite chokes around it to serve as what we call a dirty ballon. So I pulled it out of all of that and so put a PL-259 on it, and it is currently screwed into the end there of the ZS6BKW. And those of you who have been on the channel for a while know that ZS6BKW came from ni4l.com. Mr. Chris Fox, he builds the best version of that antenna that I've ever seen used, and everybody I've recommended them to have been quite pleased with them. So I wanted you guys to see that because of what I'm going to be doing in this video. So what am I going to do today? Well, it's time for me to get rid of the RG8X, and I'll say this, it's not damaged or anything. It's amazing. It's very old. You would think that it would be not even 50 ohms anymore. I've had that happen with coax. Be aware of that. Coax being outside, exposed to sunlight, it may not remain 50 ohms for 30 or 40 years. I've had some that actually did go bad in that way. Not that it couldn't be used, by the way. So let me say, I gave such a coax to my brother, W4KWM, and he used it to build a single band 60-meter dipole. And when you're making a dipole, you're just going to get it close with the math, and then you're going to tweak it by trimming the ends anyway. So he basically compensated for the coax not being exactly 50 ohms anymore, and he's got a wonderful antenna. It works great. And he's part of the reason that I'm going to do what I'm going to do today. He bought a ZS6BKW as well. In fact, he got his before I got mine. And Joel got one. You've heard me talk about Joel. Joel got one even first. And so I had discovered it by looking for Joel. On behalf of Joel, I was looking for a stealth antenna that he could use in his neighborhood that doesn't allow antennas. So so he was the first one of our little group to get one, and it just performs very, very well. So then Wayne got one, and he with 100 watts, has just worked the world. Well over 10,000 mile contacts with that thing. 5.7 to Japan with a 100 watts. Well, what did Wayne do? He's got LMR 400 connected to his. Loss through that coax is so minimal. It's amazing. It's rivaling ladder line. I mean, it's getting close to rivaling ladder line at HF frequencies. So the other thing is you can run full legal limit through the LMR 400, and you can't with RG8X. And I'm afraid I've pushed this one a lot. So I'm going to change it out. and here's what I'm doing. I'm going to switch it out to this. This is 75 feet because, well, you can buy 75 feet of LMR 400 already made up. Now, I am actually going to have to cut one of the ends off. I normally do when I bring it into the house, and this video is going to include showing you how I get this into the house. And let me show you what I'm going to use. I'll put the link for this device. It's a cable Gland, G-L-A-N-D. I bought this on Amazon. Be very careful, the ones on eBay. I ordered one, didn't fit. It said RG8, but nope, didn't fit. But, you know, LMR 400 is about the size of RG8, and there you see the center hole. That is big enough for the RG8 cable to go through, but not big enough for the PL-259. So I'm going to cut the PL-259 and feed that through, but you can see how this works. I will drill a hole in my house, in the siding. Fortunately for me, I have a drop ceiling in here where the shack is, so all of my cables come through a similar type hole, and so different type than this was. I haven't been able to find the ones I used to use. It was basically a clear plastic tube. But I'll take this and I will drill a bigger hole, a big enough hole that the coax can go through, and then 4 more holes to screw this into the siding. And that'll come into in between the floors, above the drop ceiling, but below the floor above me. And then I'll route that over here to to where the radios are. Continuing this video of where I'm installing LMR 400 to replace the RG8X. So you'll see up there where my original cables went through, there are three holes. That fourth is for cable TV or internet. And the guy that put that in, he wasn't concerned about making it the same, you know, in the same plane with the other 3. I measured it down. But, all right, so I'm gonna put a 4th one in, and I just went inside the house and checked. There's a drop ceiling in there, so I'm able to climb up and see. You might think, well, put the 4th one between the cable wire and the one that's got the RG8X and an RG8 going through it. Well, there's a stud right there, so I'm going to have to go to the right side of where you see the cable TV cable coming in. So I'll go on the right hand side of it, and so that should get me a nice spot to enter into the house with the LMR 400. Okay, back in the house, there you can see I've got the drop ceiling pulled back. And if you look up in there, you can see where those cables are coming through. That white piece that's hanging on the cable, well, the other 2 have it all the way up against the insulation. But since I brought an RG8X and an RG8 through that one, I couldn't fit both through that white insulator. So as you can see, the RG8 was the afterthought. RG8X, sorry, the smaller one, was the afterthought. So there, see that blank area right there? There's that stud I was talking about. So the blank area to the left, looking from the inside of where that cable is coming through for the internet, that's going to be where I'll put the hole. All right, catch you in a minute. Okay, the hole is cut, drilled through. You can see the sunlight. Now I'll go to the outside and work the cable through. Okay, I'm just using the roof of a little bike shed here under the deck as a staging area, so I have to take the cap off of the PL-259 that comes installed on the cable. I'll be cutting it right here to fish it through because it won't go through with the connector on it, and I'll just put another PL-259 on it when I get it in the house. This is the cable entry, called a cable Gland, by the way, sometimes. It's 4 mounting screws. So let me get going. Okay, so the connector's cut off the end. Hate to waste it, but I'll be using a better quality PL-259 than that anyway, and I'll solder it on. Okay, the cable's pulled through. Always be sure to put the cable Gland on the cable before you push it through. Now I want to talk to you about this LMR 400. This cable is somewhat stiff and you cannot kink it up, so I'm going to very carefully unroll it straight and get all of those coils out of it. Okay, carefully just straighten out this LMR 400. so you don't have any of those tight coils in it. It'll further straighten once I get it woven through the rafters up here. I don't want to coil it, but I've got to use up some of the length because I'm not going to need all 75 feet to get to the radio. But what I am going to have to do is use all 75 feet because the ZS6BKW requires a minimum of 70 feet of coax. The cable is actually already routed inside. It's up to the back of my tuner while connected. I've got to put the PL-259 on in there, and that'll be the end of that. Now I'm about to mount this to the wall, and then I'll route the rest of the cable that I have to do something with, short of coiling it up. So the screws that I'm going to use, they came with this mount, and they're somewhat self-tapping, but I'm going to take this small bit and drill a pilot hole, but I don't want it as big as the threads of the screw, of course, because, you know, I want the screw to bite into the siding. I'm going to drill opposite holes first. You know, I'll drill this one, and I'll actually put a screw in it, and then I'll make sure it's lined up. Then I'll drill the opposite corner. Okay, so you see the two opposite corners have screws in them now. I'm going to go ahead and tap the hole for the other two and screw those in. Okay, all 4 screws are installed. I'm not going to tighten this outer ring here until I've tested. And I'm actually going to come back and put a bead of silicone here to help keep this waterproof. I'll also put some in here. Okay, I'm going to leave that protective cover on this end, the PL-259 that came already installed on this. And by the way, there are lots of different LMR 400 cables out there. I bought this one at Ham Radio Outlet, ABR Industries. So I'm going to use up some of the excess by routing it, just snaking it around all these. I've got some hooks up there, and you see these beams that go across the port beams, so I'll just lay it up over there. I've got a hook over there. I may be able to route it through. Just going to use up some of this excess because, as you see, there's where I connect the coax, right there. So this is the RG8X. I'm just going to leave it out here as a backup, straight up there. At approximately, I don't know, 48, 50 feet, that's about 39, a little over 39 feet down. And then the center point's up there, so it might be 48 or 49 feet. I'm 6 feet tall and I can't reach it, so it might be close to 50 feet. Okay, I'm gonna lower that down now, and I'll be able to connect the cable. You see this rock tied to the rope? That allows the antenna, as the wind blows the trees, allows the antenna to move around a little bit. The rock will just settle back down when the wind stops. But what I'm going to do is I'm going to use the rope. I've got a hook that it routes through right there. So I'm going to bring the rock up to that point so I can pull enough line down, enough of the RG8X down to disconnect from the antenna and reconnect the LMR 400. Okay, so you see, I've got it down now. This is an earlier version of the ni4l.com ZS6BKW. You see how the ladder line connected there, and there was this rope for strain relief. I covered up the connections here with silicone so that when the rope got wet, it didn't conduct and cause well, essentially a short. It would mess up the SWR. The newer ones are weather sealed now. They've got a different type of connection here, but that did the trick for me. I should point out that I used coax seal to weatherproof this PL-259 connection. I'll be peeling that off and putting a fresh sealant wrap on it. It comes like electrical tape, and so you just apply it similar to how you would electrical tape, but trust me, this stuff will not let water in. I mean, I can tell you right now, it's sealed. I can't even really peel it off. I'm going to have to cut it off. Okay, look at that, how dry. The old PL-259 is disconnected. Yeah, so this is what the old SO239 connection was like for the NI4L version of the ZS6BKW. The new version has the SO239, the connector here, recessed up inside of it for additional waterproofing. Okay, I'm going to remove the green hood and hook this up. Okay, so the PL-259 is screwed in. Here's the Coaxial tape. I will apply that next. Okay, the Coaxial tape is applied. And let me explain something about when you're applying this stuff. It's not going to be sticky like Scotch 33 or any type of electrical tape. But what you want to do is, I started down here, and as I wrapped, I stretched it. In other words, pull it a little bit tight to where it stretches a little bit. And when you first start it, you're just going to have to hold it with your finger and wrap it around all the way and let it grip itself. But like I said, pull it a little bit so it stretches, and then do that all the way up. And I of course put a little bit thicker, several turns here at the PL-259. Okay, I'm going to raise the antenna back up and go inside and solder the connections and run some tests. So you see my rock there. All I have to do is uncoil it here and let it pull the antenna back up. I'll get a little bit of an assist there. There's more weight now with that heavier coax. All right, there we are. Let's take a look over here. Sorry for the sun glare. Hey, but I'm glad for a sunshiny day. There we go. Now I'm going to take a little bit of this slack out here. I don't want this to be to the point where somebody can reach up and grab it. And then I'll tuck that slack in under the porch. Okay, N4 H&H back in the shack, ready to put on a PL-259. Amphenol here. I prefer Amphenol. I bought these as a kit, so you get the reducer for RG8X, so I won't be using that. So here we go, open this up. Okay, I'll put that away. So here is the end of the LMR 400 that I cut off. I'm going to take my knife and just cut this extra rubber piece off that's left over from the seal that they put on it. Okay, one of the very first things you want to do, and this one's actually put on backwards, but you just want to get the, there we go, get the part that you tighten taken off, and the first thing you want to do is put that down the coax with the knurled part, the rough part that you grip, facing the end that you're going to put the PL-259 on. Now this is the way I learned to do it at Motorola, so I'll just do it this way here. I'm putting the PL-259 next to the coax, and what I want to do is I want to trim the rubber of the coax, or the plastic, PVC, what have you, back to right where the threads are, right here where these threads are. See there? So I'm going to put a little indentation there with my thumb, and I'm going to cut around that. Yep, I'm beginning to see the shield down there. I'm just barely wanting to cut through here, just enough to break the rubber, but not the shield. Okay, I think I've got enough of it. I can start. What I'm going to do is I'm going to put a little line down the middle here with a knife, score it, and try to peel that back. There we go. So that exposes the shield. And now I'm going to tin this with some solder. Tin this shield all the way around. So now one of the things that'll help is use a little bit of the flux here. So I'll put a little flux around there. Okay. Flux, I've had that for years. Kester SP30. Okay, now I'm going to take a pistol iron, and I've had this since I was, since I first got into electronics as a child, really. I mean, I guess I was around 11, and my dad bought this for me. You want to use a pistol iron because you're going to need maximum heat, so you don't have to stay on it so long before you, you'll melt it. If you try to use an iron that doesn't have enough heat, you might begin to degrade the insulation, the dielectric here inside, what separates the shield from the center conductor. So you don't want to use a pencil iron. You got to use something that's got some serious heat to it. This is you got two positions, and in the second position it's 140 watts. In the first position it's 100. They make some that'll give you 350 watts, and that's even better. Okay, so now I'm going to do the tinning. Don't need to tin all the way out to the end, by the way, because we're going to be cutting that off. But I do want to tin a little bit farther than where I'm going to cut. And this will make sense in a minute. It's a little bit more difficult to do when I cut. I've brought the coax in only up to the length that I need it, so it's actually not the most ideal way to handle the coax. Now, those of you who have a background in citizens band, you may have seen people just take the shield and fold it back over the rubber part and then just screw the PL-259 on there. And that may be okay for, 4 watts, 11 meters, but especially when you're getting into higher frequencies, you want to do this way. But I do it for HF or anything because I want a very strong connection. All right, so now I'm going to take my knife, verify my cut point. Now this time where I want to cut is going to be, okay, I hope you can see that. Let me look at the camera to make sure you can see that. So I'm going to cut here so that I'm basically leaving about as much shield as there is a gap here. Because you see those holes? We're going to be putting solder through those holes. So I'm going to actually take my knife now and I'm going to cut through the shield right there. All right? I'm going to make a score mark. And I will tell you, when I worked at Motorola, I had a knife that it wasn't exceptionally sharp, but it wasn't completely dull. It was, I think, I can't remember the brand, but it's one of those with a wooden handle. And its only purpose in life, in my toolbox, was for what you see me doing right here, because this is tough on a knife. I don't do it for a living anymore, and I don't know what happened to that knife, so I don't, I'm punishing my little Swiss Army knife here, really, doing this. I may have to go get another knife. Hold on. Okay, I was able to get it with the Swiss Army knife. It just took a little more effort, but there we go. And I'm just going to pull the rest of that off. By the way, it just kind of rotates off because of the wire spiraling inside, so don't just try to pull it straight off. You may have seen me, I kind of thumbed it a little bit and rotated that off. Okay, now it looks like this. Let's double check. So you see, the amount of shield that I left matches up with that gap where the holes are. Now I'm going to do one more thing. I'm going to tin this area here so that it'll be ready for soldering inside for the center conductor. Heat up the iron. Now, you know, when soldering, the idea is not to melt the solder and get it to stick to the surface. The idea is to heat the substrate, or, you know, the thing that you want to solder, heat it, and then let the solder melt to it. That way you will prevent what we call a cold solder joint. Okay, the end is all I really need to tin. That's enough right there. And now I'm going to check the length of the end. Yeah, it looks like it might stick out just a little bit far, so I'm going to clip just a little bit of the end off. There we go. Now, put the connector over it, and then there are some threads inside of here that will grip that rubber as you screw it on, or the PVC in this case. And again, don't forget, before you go screwing that on, make sure that the outer ring here that you tighten with is already on the coax, with the knurled part that you grip toward the end where the connector is. Okay, let me raise the camera a little bit there. All right, so all I'm doing now is just using my hand pressure to screw this on, and I'm looking inside the holes, and I'm beginning to see the shield that is tinned. I might split this video up in two and make one of them be entitled how to put on a PL-259. There we go. Now I'm looking through the hole, and I can see through the hole here all the little tinned the shield that it has solder already on it. So now I'm going to put a little bit more of the. This is optional, but it just helps it makes it a little bit easier. Put a little of the flux there. And now, if I can get this coax to stay put, heat up the iron. And this time I want the connector to heat up, and it's going to take a little more heat. This is why you use a pistol iron. All right, there we go. That should be getting pretty hot now. I'm just going to hold it there. Test it a little bit. So since the shield inside is already tinned, what should happen as this connector heats up is the solder here should just start melting into the hole, and it's doing so. And then it will melt the solder that's on the shield. And that's what it'll look like. Oh, let me get that in the camera. Hope you can see that. All right, and now I'm going to work my way around. Let me see if I can get some more light on this. Okay, so you can see that the solder there, see the hole, right? See the solder is molten there and is connected to the shield on the inside. Here's a hole. See if we can get that in focus. See, that one's not been done yet. So I'm going to work my way around and do the other three. Again, heating the connector and then letting the solder flow into the hole and melt the solder that's on the shield. Okay, so all four are done. Ooh, it's still hot though. Letting it cool a little bit. But all four sides are done. As you heat this up, you know, some of the solder that you've already put in the other holes might run a little bit, so just go around and touch it up a little bit to make it neat. Wish you could see that a little bit better, but that's all the light I have. This is not a professional studio. This is a ham shack. But, you know, just go around it and make sure it looks okay. Now I'm going to solder the end. One of the reasons I like amphenol connectors, that insulator there, the material it's made out of can take heat. Some of the cheaper PL-259s have plastic in there and they'll melt when you start to heat this tube here for the center conductor. All right, so I'm going to heat that up and put my solder in there. When the solder starts melting, yeah, there we go. I will check it. And this is going to be one where ultimately, before you totally finish this one, you want to aim the connector down just slightly. And you might accidentally get some on the barrel of it, so you want to check that too. Now what I'm going to do, let it cool here for a few seconds. I'm going to take my knife and go around and scrape any solder residue, also any of the flux from the solder. Yeah, I got a little spot of solder right there that built up. Came off the tip probably from the other spots. Now let's take a look at the end and see how it looks. Yep. Okay, see the end? So that's good. It's okay if it balls up a little bit there too, but that's good enough. I'm not gonna heat it any more than I need to. Okay, so that is how you install a PL-259. And we're ready to plug this into the back of my antenna tuner and test my ZS6BKW. Okay, so hope you can see all this. What I've got is some of this plastic tubing here that's split that I can tuck this coax into and bring it down neatly to the back of the tuner. So I'll go ahead and do that. I'm trusting that everything is okay. Okay, so it's all tucked in. The rest of those, that coax is for the off-center fed dipole. The rest of these are for well, my 2 meter, 70 centimeter, my R5 vertical come in that way. And the now, well, there's that RG8X that was feeding this ZS6BKW, and now there is the LMR400. Yeah, and what am I going to do with that RG8X? I'm not going to do a thing right now. I'm going to leave it intact. All I've done, let me get back here and show you. All I've done is unscrew it from this connection here on the back of the PAL-Star tuner, and that is now the LMR400, and the other one's hanging down there somewhere. So maybe I'll use it for a dedicated receive antenna, something like that in the future. Okay, here we go, the final test. Everything's hooked up. I'm on the 40 meter band. I'm gonna turn on up here in this screen here. Gonna hit the power button, turn on the Elecraft KPA 1500 and use its SWR meter, which I find to be quite accurate. As a matter of fact, the power scale as well is quite accurate. Okay, now let's see what we're getting here. Well, we're on CW right now. Let me switch to, I'll move away from where they are. Lower my power level to 20 watts. N4 H&H testing, N4 H&H testing, 1.1 to 1. Try a quick carrier. Indeed, 1.1 to 1. Try 40 meters. I'm sorry, 20 meters. There we go. That's the high end. Let me go down here toward the, more toward the center. Okay. N4 H&H testing, and that's showing 1.2. These antennas are working off of harmonic resonance points, so it doesn't necessarily fall exactly into the center of every band. 17 meters. 17 meters is another resonant band for this antenna. Okay, so tolerable resonance. Well, it's busy today. Okay, I'm only at 20 watts. N4H&H testing. N4H&H testing. 1.5 to 1 at 18,135. I'll take that. 12 meters. N4H&H testing. Okay, that's running around 2 to 1. But that's all, you know, all tolerable. It should also work in the there we go, in the FM portion of 10 meters. So let's see. N4H&H testing, N4H&H testing. Yeah, 1.5 to 1. So that's good. That's good. Lower loss now with the LMR 400, and the good news is that works both ways. So I'll go out now and I'll go ahead and seal everything up with the silicone seal and call it a day. Okay, out here to button this up. So you see what I did? There's a little drip loop there where that, there we go, it's where that coax enters the house. And I just, you know, routed it across the underneath of the deck here, securing it where I could. It goes over that way, and then back this way, and then that way out to the antenna. Let me show you how that ended up. So here it is. Oh, it's a good 10 feet off the ground, and so that puts it at about 50 feet up to the center point. So now what I'm going to do is climb the ladder and seal the entry here with some clear silicone. Okay, and that'll wrap it up. Thanks a lot for watching. If you would, please like the video and subscribe to the channel. If you want to help out to keep this kind of content coming, you can become a Patreon at the address on the screen, the patreon.com/N4H&H. Again, thanks for watching. Hope you found this helpful and informative. 73 from N4H&H.